Okay, hello again, chemistry class. This is Coach Jeans, and I hope you're doing well today. Today, we're going to take a look at an introduction to stoichiometry. So, you should be in your composition notebook and the unit on the mole and stoichiometry, and turn to page 11. Now, we're talking about stoichiometry. That is a word you're only going to find when you're talking about something in chemistry. You usually don't use the word stoichiometry in everyday language. It's kind of a specific term that we use in chemistry. Technically, what it is predicting quantities in a chemical reaction. Another way to say it is just, how much stuff can you make from some amount of other stuff? So if I give you a certain amount of this chemical, how much of this chemical can you make? Or if you want to make a certain amount of chemical, how much chemicals do you need? Now, this is real important in industry and other types of things that deal with chemicals, because you don't want to waste chemicals. Chemicals are expensive. And so it's important for an industrial chemist to be able to figure out exactly how much of a certain chemical he or she needs in order to make the product, so they will limit amount of waste and increase profit margin for the company. All right, a good analogy of this is like making a ham sandwich. If you're making just a really, really basic ham sandwich, you're going to need at least 2 slices of bread, at least 1 slice of ham, and you put those together, and obviously that makes 1 ham sandwich. Now, we know that to make 2 ham sandwiches, all we need to do is double everything. So we need 4 slices of bread. We need 2 slices of ham. Very, very easy. All we have to do is look at it. And this was sort of like a chemical equation. Usually we don't even have to write anything out. Usually we can just do this in our head. We know how to make ham sandwiches, and we can figure it out really, really quickly. Doesn't take a lot. Well, this is basically what stoichiometry is, except for we're going to have to do a little bit of calculations on these, all right? Now, take a look at this graph right quick. If you have a balanced chemical equation like N2 plus 3H2 yields 2NH3, so you have nitrogen gas plus hydrogen gas yields you ammonia. There's a lot of different things that this can represent. It can represent 1 molecule of nitrogen reacting with 3 molecules of hydrogen gas to give you 2 molecules of ammonia, NH3. All right. It can also represent moles. If you'll go down a few, you'll see that you have 1 mole of nitrogen plus 3 moles of hydrogen gives you 2 moles of mercury. And then we can also take that over to grams, because if we know the molar mass of N2, then we can see that 1 mole is 28 grams of nitrogen. We can have 3 times 2 gives you 34 grams, 3 times 2 mercuries. Okay. So that's going to give you that would give you 3.03, and then so that adds up 28 plus that gives you 34 grams, and then that will leave you with 34 grams of your product. Make that 3 times 6 times your hydrogen, which is 1.01, gives you about 6. So 28 plus 6 is where you get the 34. Also, since these are gases, assuming it's at standard temperature and pressure, we could say we have 22.4 liters of nitrogen gas. We could add up 3 times 22.4 gives you 67.2 liters of hydrogen gas. That will give you 44.8 liters of ammonia. So you say, well, that's a lot of information. Okay, let's try to simplify some things out. Well, a chemical reaction is just like a recipe, just like a ham sandwich recipe or any kind of recipe. Recipes have ingredients, and ingredients have ratios. And so when we look at this chemical reaction, we can see that we have some ratios. And the main thing we want to look at is what we call our mole ratios. All right, so there are 6 mole ratios in this equation. Let's see that if we can write those. All right, so we have the basic chemical equation. We have we have N2 plus H2 yields NH3. So we have 2 of those and 3 of those and 1 of those. So what are my mole ratios? Okay. Well, we look at this and we simply are going to look at the coefficients. So if we compare nitrogen to hydrogen, well, we have 1 mole of N2 for every 3 moles of H2. All right. Or we could say we have 1 mole of N2 for what? Every 2 moles of NH3. Okay. We could also say that we have 3 moles of H2 for every 2 moles of NH3. All right. So those are 3 of the mole ratios, but I said on the side that there are 6. Well, what are the 6? Well, what you can do is you can flip these. You can write the inverse of them. Just flip them over, right? And if you flip them over, you'll have 3 moles per 1 mole of nitrogen gas, or 2 moles of ammonia per 1 mole of nitrogen gas. Or you could say you have 2 moles of ammonia for every 3 moles of H2. So these are what we call mole ratios. And we use these mole ratios when we do calculations. And if you haven't already done so, you'll want to get out that mole roadmap that we made in class. You'll want to get out your periodic table and your calculator. And so pause the video. I'm going to do that right now and get your mole map out, your calculator, and your periodic table. All right, so you've got those materials out. And in your notebook, I want you to copy this screen down. I want you to copy these stoichiometry rules. So pause the video again and jot down these rules. Okay, in your stoichiometry rules, number 1, you must always start out with a balanced chemical equation. So that is essential. And so sometimes you're going to be given the chemical equation. It may already be balanced. If it's not, you need to balance it. Sometimes you're just going to be given it to you in words, and you're going to be able to have to write out the correct chemical equation and balance it as well. The second thing, what you're going to do is you're going to write down the known amounts under each chemical. So you put down whatever quantity is given to you for that chemical and also put the unit with it. Third thing you're going to do is you're going to put a question mark along with the unit by the chemical in question. In other words, what the problem is asking you to find. Put a question mark underneath that chemical in the equation. Put the unit you're trying to go to in that equation. This will help you out. And then fourth thing you're going to do is you're going to do a T-chart to determine the amount. Now, again, T-chart, that's just what I call dimensional analysis. I picked this up from another teacher and I adopted it. So it's dimensional analysis. Some people call it factor label method. Whatever you call it, it's all the same thing. I call it T-chart. All right, so let's take a look at some examples of this. And on your outline, you have some examples. All right, starting there on page 13 of your outline. And if you haven't already copied these down, then you'll need to pause the videos right here and copy these 2 examples. Example number 1, copy the equation along with the problem. And example number 2, do the same thing. Okay, so in example number 1, we've given the equation. We have 2 potassium chlorates, yields you 2 potassium chlorides and 3 oxygens. The question says when 2.2 moles of potassium chlorate reacts, how many moles of oxygen are formed? Okay, so we always start out with a balanced chemical equation first. All right, so we have example number 1, and our balanced chemical equation is given to us. It is 2KClO3 yields 2KCl plus 3O2. But I don't worry about state symbols for these. Now, the problem says when you have 2.2 moles of KClO3. So that's the given amount. That's the quantity we're going to put here. And it's moles, and it's KClO3. And then it says how many moles of oxygen are formed. So we're going to put a question mark underneath the O2, and we're going to put moles because the question says how many moles. All right, so we're going to take a look at our mole roadmap. And you're going to start on the left side with the given. And you're going to start with moles because it's given to you in moles. And you're going to go to moles unknown. So to go from here to here, you travel this road. So you're going to use what's called the mole ratio. Where do we get the mole ratio? From the balanced chemical equation. All right, so let's take a look at how that's done. So we're going to do our T-chart, our dimensional analysis. We're going to put 2.2 moles KClO3. We're going to draw our lines, which looks like a big fat T. And then we're going to put moles of KClO3 on the bottom. And we're going to put moles of O2 on top. Then we're going to look at the mole ratio. Well, the number that's beside the O2 is a 3, so that goes on top. The number that's beside the KClO3 is a 2, so we're going to put it on the bottom. All right, moles, KClO3 cancel out, and we have moles of O2, and that's what our problem says. So now we look at our calculator. We punch in 2.2. We hit times 3 divided by 2. So on top you multiply, so on bottom you divide. And equals, and we get 3.3. Well, 3.3 what? Make sure you include a unit. It's moles of O2 because that's what we have there. All right, so that'll answer that problem. All right, let's go on to example number 2 on your sheet. All right, so hopefully you've copied this down, but if not, you'll want to pause the video right here and you'll want to copy example number 2. All right, so we have the same chemical equation. This time it says when there are 0.0045 moles of KCl is formed, how many moles of KClO3 has reacted? All right. So we're going to start out with the same chemical equation. Okay, good idea to go ahead and copy it down again. Okay. Now the problem says when 0.0045 moles of what? KCl. So KCl that is. So 0.0045, what's the unit? Moles. All right, then the question says how many moles of KClO3 reacted. So we're going to figure out how much stuff we started with. Okay, kind of working the problem in kind of a backwards way. We do it the same way. We put a question mark underneath the compound that we're trying to find, the one in question. So we write 0.0045, okay, moles of KCl. We draw our T-chart. We put moles of KCl on the bottom and moles of KClO3 on top. And so now we look at our mole ratio. And so we have a 2 on top and a 2 on the bottom. Moles of KCl cancel out. Well, 2 over 2, well, that's the same thing as 1, right? Because we can cancel those out. So we don't even have to use a calculator for that, obviously. And so it's 0.0045 moles of KClO3. Okay, getting the hang of this? All right, so let's take a look at a little bit more complicated one, all right? Example number 3. So again, look on your outline. Here it is. It's kind of at the bottom, got cut off, so we have to flip it over. But it's the same chemical equation. Now we'll flip it over, and at the top of your sheet right here, here's the problem. If 12.3 grams of KClO3 reacts, how many grams of O2 will be formed? So pause the video and copy that question down if you need to. All right, so again, we have the same chemical equation. 2 KClO3 yields 2 KCl plus 3 O2. The question says if we have 12.3 grams of KClO3, so at 12.3 grams, how many grams of O2 is formed? So this time we're going to figure out here, and this time we need to go grams. So this is what we call a grams to grams or mass to mass problem, all right? So let's take a look again at that mole map and kind of figure out what we're going to do here. All right, so we're starting on the given side with mass right here. So we've got to first convert to moles. We've got to get it to moles. We have to do that by using the molar mass. Then once we get it to moles given, we can convert it over to moles of the unknown. The problem says, though, we need to figure out grams. So we need to go one more step, and we need to figure out grams by using the molar mass of our unknown. So how many steps are we going to do? Well, we're going to go here to here. That's one step. Here to here, that's 2 steps. Here to here, that's 3 steps. So this is really a 3-step problem here, okay? You'll get the hang of this as soon as you see how we do it. We start them always out the same way. We take what's given along with the formula, and we put that in our first box. We draw our T-chart. Whatever unit is here must go down here. So that it cancels out. If you're not sure what to do, look at your mole map. You say, well, I don't have a mole map. Well, make one. Or if your teacher doesn't let you use one, then always convert it over to moles if you're not sure. So moles of KClO3 on top right there. All right, now I'm going to go ahead and carry it out with the units, and we'll come back and we'll put the molar mass right here, right? The one's going to go beside the mole. Now, moles of KClO3's got to cancel, so it goes to the bottom. Okay? Now, what are we going to? Now we're in the middle of our mole map, all right? So we've got it right here. Now we're going to convert it over to here. So what we're going to use is the mole ratio. So now on top, I'm going to put the mole of the unknown. Well, what is the unknown? Well, that's the one I put the question on. So that's O2. Okay? So now I can use my mole ratio. Well, what's the mole ratio? Well, there's a coefficient of 3, so that goes beside the O2. There's a coefficient of a 2, so that goes beside the moles of KClO3. All right? Now we can carry this on out. Whatever unit's here has got to go down here to the bottom. All right, now we can convert it over to what? Well, look at your mole map. So we've got to moles of unknown, and our problem says how many grams. So we've got to go here. Moles to grams, we're going to use the molar mass again, all right? So we're going to put grams of O2 on top. Now, we can put a 1 beside the mole here. Now let's make sure everything cancels. Moles of O2 cancels. Moles of KClO3 cancels. Grams of KClO3 cancel out. And so everything cancels except our last unit. So therefore, we know we got it set up right. Now we just need to make sure that we put the correct numbers in everything. All right, so we need to calculate the molar mass of KClO3. So you should know how to do that. And when you calculate that, you should get about 123 rounded to three significant figures. And then we'll need to go over to, did the problem say, let's see, what does the problem said? Problem said how many grams. So now we need to go to the molar mass of O2, all right? Well, that's 16 times 2, so that's 32.0. Now we use our calculator, and we punch in 12.3 divided by 123, and then we go times 3 because it's on top. Remember, if it's on top, you multiply. If it's on bottom, you divide. Divided by 2 times 32. So again, I'll go through that. 12.3 divided by 123 times 3 divided by 2 times 32, hit equals, and you get about 4.8 grams of O2. All right. So that helps us out with that problem right there. Okay. Now, let's take a look at example number 4 here. Okay. Or well, it says example number 2, but it's example number 4 on our list. So again, we're starting out with the same chemical equation. And now we're going to convert over to something different. It says how many liters. So it says if we have 4.53 grams of KCl reacts, how many liters of O2 will be formed? All right, so a little bit of a twist on that. We'll show you how to work that out as well. All right, we'll just call this example number 4. All right, so again, we have 2 KClO3. Always start with the correctly balanced chemical equation. All right, now the problem says we have 4.3 grams of what? 4.53, excuse me, grams of KClO3. We're going to try to figure out O2 again, but this time we need liters. Okay, so we're going to start out again with whatever's given to us, 4.53 grams of KClO3. We're going to put grams of KClO3 here. We're going to go moles of KClO3 here. Okay, so if you don't know what to do, always go to moles. So we look at our mole map. We're going to start out with grams. We're going to go to moles. Then we're going to go to moles unknown. Then we're going to go to liters. So we're going to go 1, 2, 3 steps, but this time we're going up here to liters. So we're going to use that conversion, the 22.4. All right. So now this is the same, 123 grams. It's our previous example. All right. We're going to have moles of KClO3 and moles of O2. Well, those ratios are 3 to 2, just like we wrote above. Now, here's where it changes. We're going to have moles of O2 on the bottom. This time, we're going to have liters of O2. So the 1 goes here. And again, look at your mole map. What is the conversion for liters? 22.4 liters over 1 mole. That's assuming it is at standard temperature and pressure, and it is. All right, now moles of O2 cancel, moles of KClO3 cancel, grams of KClO3 cancel. Leaves us with liters. Our question wants us to find liters. So in our calculator, we punch in 4.53. We hit divided by 123. We hit times 3 divided by 2 times 22.4. And we hit enter. And we get 1.24 when we round that to 3 significant figures. And what's going to be the unit? Liters O2. Make sure that you put the correct unit on that. All right, so we're going to work plenty of more examples in class and do some practice on these. I hope this video helps you out a lot. And until next time, I'll see you hopefully in chemistry class. Have a great day.